Alright guys, so we are back. So we are going to do this weekly contest 479. So let's see how it goes. Okay, so this is a virtual contest. You are given an integer array nums. This is the array. The binary reflection of a positive integer is defined as the number obtained by reversing the order of its binary digits, ignoring the leading zeros. Okay, and okay, when I reverse the binary digits, what is binary digit? So like converting this into its binary form, interpreting the resulting binary number as a decimal. Okay, sort the array in ascending order based on the binary reflection of each element. If the two different numbers have, I can just use I can just use a reverse technique for it. Okay, sort the basis of reflection of each element. If the two numbers have the same binary, the smaller original number should appear first. Okay, so maybe I'm just going to do this function sort begin nums.end. I'm going to do use lambda function, and here I am not actually going to change the actual, or maybe I can change the actual. Okay, now what I want is the reflection of these two. So how do I find the reflection of these two? Okay, so maybe I can so I have to ignore the leading zeros. Okay, so I can try to find the reflection. Let me create a function ref which will give me the reflection of array A. So what will be the reflection? Okay, as we can see that this 4 has just I just need to sort nums only. How do I find the reflection? So reflection of this number, I can actually let me find the first appearance of the digit, like what is the first time when 1 occurs from the left side. So how are we going to find that? I can find it by this 31 minus it will give me the index of built-in count leading zeros of x, right? This is going to give me the first occurrence when 1 is there. Okay, so right now what we are trying to do, after I do that, when so if I try to find out the first element, then I have to reverse the number. So I'll have to start with r equals to let's say 0, correct? Or maybe 1, because r is that this is the time where I'll basically put whatever value is there. So let me call this place, correct? Whatever value is there, I'll if it is 0 or if it is 1, whatever it is there, I'm just going to enter into the sum. I'm going to add it to the sum. Okay, so let's try to do this. While p is greater than 0, or maybe greater than 0 works. Okay, now what I'll do, I'm going to add to the sum. What am I going to add? I have this number x. I'll be like, okay, give me that number. What is that number which is here? Correct. This is going to be the either that first digit is a 1 or 0. If it's 1, I'll be like, okay, multiply that with r, okay, and then just add it to the sum, and then I'll do it continuously, and at the same time I'll be like, okay, is less than p, I'm going to reduce it, and r I'm going to not going to do this. Instead what I'll do, I'm going to do this, correct, because this is the place value, this is the digit where it is currently in. If it's 0, it's just nothing, adds nothing. If it's 1, it's something. So, and then I'm just going to return the sum. Okay, so now on the basis of the reflection, I'll do it. If okay, so I'll have a reflection, let's say x1 which is ref of a, and x2 which is ref of b. I will like if x1 is greater than x2, return true, else if x2 is greater than x1, obviously I'm going to return false. But if none of them are true, then okay, what I should do, I'll be like, okay, if this is not the case, then I'll be like a is less than b. Okay, smaller original number should appear first. Yeah. Okay, sort the two numbers have the same binary prediction. Smaller should appear first. Return the resulting sorted array. I'm just going to be like, okay, return the nums, and I'm done. Yeah, sorry. I think this should do it. Yeah, 443586. Okay, this didn't work out well. What happened? Output did not change at all. Why is that? Why is the case? Okay, if x1 is greater than x2, why the hell I did it? Okay, this is going to be the thing, right? And then going to be something like this. Yeah. It still didn't actually work out. Maybe I have some problem with this reflection that I have. I have to kind of maybe reflection is a problem, because whenever I was dealing with 8, I'd be like, okay, it's just 1, right? I multiplied by once and then added to the sum. Right. It's p, and p I'm doing p minus minus, and when it's 1, I'm just doing it one time. Okay, when I'm at 0, I should not at all do anything. Yeah, I think I should continue till it's 0. This is probably the thing which, now it's correct, and this is also correct. Okay, yeah, so let's do the next question. Largest prime from consecutive prime sum. You are given an integer n, return the largest prime number less than or equals to n that can be expressed as a sum of one or more consecutive, as a sum of one or more consecutive prime numbers starting from 2. What? What is the max? Okay, n can be, so I can actually, in order to find all the primes, I can actually use sieve. Then let me try to think what I can do. I can actually call sieve. That will be cool. And I need to find the largest prime number which is less than or equals to n that can be expressed as a sum of one or more consecutive numbers starting from 2. Okay. Alright, so I need to express prime numbers as a sum of the things. Okay, alright. Yeah, I can just use sieve to actually find all the primes in between this, and then I'll just, from consecutive primes I'm just going to see if it's prime, I'm just going to add it to the list. So maybe I am just going to make sieve. Alright, so the function of sieve is you need a bit set, so, and also you need a, so this can be up to 5 e5, and so I'll do this, and then I'll have a bit set and composite numbers. Okay, so the first thing that sieve does is do this thing, composite of 1, 0 and 1, which is, are they composite number? Yes, they are composite numbers. And from int I equals to 2, I is less than I times I is less than or equals to, because if I go past n, right, if I go past n, correct, if I try to go past, let's say, but that particular thing has already been a multiple of this thing, so it's automatically going to be, composite. So if I see that something is not composite, then I'll be like, okay, get ready to make the things composite. Composite of j equals to 1, right? This is the what sieve is. So I am going to also create a boolean variable here, const, or maybe int bool check, which is initially I want it false, and okay, solution, I'm only going to do this if my check is all not true. If my check is not true, I'll be like, okay, do sieve. If my check is true, I'll be like, okay, don't do it again, because I've already computed everything here. Okay, so this is the thing, if check is all true, then I don't want to do this again, because I've already done it once, right? And when I, okay, now what to do, what I'll do, I'm just going to add a sum, okay, and okay, so if there is no such number, I'm just going to return 0, right? Okay, so I'm going to be like, okay, from 2 to till n. I'm going to add, and largest prime number. Okay, I'll be like, okay, now I'll try to add all of the things and see if, okay, so when I try to add it, what do you think if I try to add all of the things? I'm obviously going to be more than n, right? I don't need to check for all of them. That's what I'm trying to do. So how much do I need to check so that, you know, the sum, when the sum actually reaches more than n, if the sum reaches more than n, if sum is greater than n, return 0, and if it's not, then else if sum is equals to n, then return I, correct? That's what I'll do. And yeah, to find the largest, what do I need to find? Okay, I need to just, you know, find the sum. Else if composite, it's not a composite number, if it's not a composite number, then sum plus equals to I. This is what I'll do, and then I'll just return sum. That's it. Okay, what's happening? Okay, it's private. Yeah, so I need to make it public. This solution should always be public. I forget. Yeah, so I think now it will work. Okay, so output is 0 for some reason. Oh yeah. Okay, so I also need to be like, okay, less than or equals to n. Yeah, right. Yeah, I also need to be careful about doing one of the things. Wait, let me show you. It wants to find the largest prime number less than or equals to n, and I'm not doing that. I'm just checking this thing. I will delete this. Okay, so temp is equals to if it is a prime number. Okay, less than or equals to temp. So I started from 2. Okay, so well, first of all, if I find a number now, like initially temp is 0, and now I'll be like, okay, if I find out that if I find out that sum, okay, if n is this much, if I try to sum it up, then it's going to be a huge number, right? If I try to sum all of them. So as soon as sum is greater than 0, I stop. If sum is greater than n, I immediately break. I don't want to continue. Correct? If it's not, then I'll be like, okay, give me the more sum. Wait. Okay, yeah. I'll be like, okay. Now if sum is greater than n, I'll break. else if it is not, then I'll do this. If sum is there, if it's a composite number, I'll be like, okay, make temp as sum. If it's not a composite, if it's a prime number, then I'll be like, okay, make temp 1, right? Temp as sum. And then again I'll do this, and it's not, and then I'll try to do all of this, and then yeah, so I'll be like, okay, temp is a thing. Okay, 17 to which is the correct answer. So let me try to submit this. Yeah, so it did work. Alright, let's talk about this question. You are given a positive integer HP and 2 positive 1 index integer damage. Okay, so this is my health point, this is my damage, and this is my requirement, and I don't know what requirement it. These are 2 positive 1 indexed arrays. Yeah, 1 index arrays. There is a dungeon with end trap rooms. There is a dungeons with end trap rooms. Okay. Numbered from 1 to n. Entering the ith reduces your health. Okay. So there are n trap rooms numbered from 1 to n. Okay, so n trap rooms. Right. There are n trap rooms numbered from 1 to n. Entering I reduces your health point by damage I. Okay, so if I enter at the ith dungeon, after that your health point, if your health point is least requirement, you earn 1 point from that room. Okay, right. So score is be the number of points you get if you start with HP health point and enter room J plus 1 in this order. Okay, J plus 1 to n in this order. Return the integer. Okay, score J. Okay. All right. Yeah. So I think this is quite a hard task. Okay, so once you start with the damage can never be negative, as you can see, right? So once you start with a health point, and damage will at least be 1, so there is always that you are going to reduce your damage, correct? So when you enter the first dungeon, you'll be like, okay, you reduce a health point, and now is your health point greater than the requirement? When your health point is not greater than the requirement, if your health point are at least you want 1 point, if it's not, then you earn 0 points, right? Then you earn 0 points. All right. Okay. Yeah, so if I try to start from let's say nth dungeon, right? Okay, I am closing WhatsApp for a while. Yeah, so if I try to start from the first, let's say first dungeon, I'll be like, okay, see, I have an n squared solution, right? But n squared won't work because of, the length is nearly 1 to the power 5. So I'll have to come up with something different. But before I come up with something different, I just want to say that if you are at a particular J, let's say, right, and you are starting from there, and your health point is HP, correct? So you'll be like, okay, now I have entered that jth room. So I entered the room J and I got some damage. Correct. Got some damage. And after I got some damage, HP has reduced to something lesser. And now I'll be like, okay, can it fulfill the requirement? I'll be like, yeah, it can fulfill the requirement. So I'll be like, okay, let's go to the next point, next thing that we'll have. They're like, oh, it still can fulfill the requirement. Yeah, then just go. Well, it cannot fulfill the requirement because as you can see, the damage I and requirement I is 10 to the power 4. So yeah, okay, correct. Yeah, so I need to come up with something smart. Okay, so if I start from the ith index, I'll be like, okay, my health point is HP, and if I enter the room J, I'll have some damage, and after the damage I'll see what is the requirement to be in that room, and if I fulfill the requirement, then I'll be like, okay, add 1 to the point, add something to the answer. Correct. Okay, so what can we really do? Okay, so one of the things that I can do is, like, if I think about brute force, it's just start from the first and see how much the requirements are, and if it fulfills the requirement. Previously, if it fulfilled the requirement, now in the second time it's still going to fulfill the requirement. Correct. So you just need to care about those which cannot fulfill the requirement. So maybe I should have some set of points, correct, set of, or maybe maps, be something like visited vector bool visited and correct. Basically what I want to do is I want to store from first, let's say from first index to the last index, how many are there in, how many are there which I have already, it fulfills the requirements. If I can find out that, then I'll be like, okay, I don't need to check it again, right? I don't need to check for it again. I just add them, and whatever I have not done, I'll just check on those, correct? Alright, that's what, but that's not going to actually give me what I want, right? Okay, this is hard. I'm trying to do this, but it's still not enough, actually. Still not enough. I need to think something different, something more elegant. Okay, what can I think? So I'm thinking of something like, it has some damage. I can maybe try to change this damage vector by D. Okay, so one thing that I'm thinking of doing is, let's say I have something like this, right? Maybe random numbers, okay? And I am here. I want to know how many times can I fulfill the requirements here, right? And I can not I will not be able to fulfill the requirements more than this particular index. If the index is 4, I will not be able to fulfill the requirement more than 4, right, for this cell. Similarly, for this cell I cannot do it more than 2 times. So I need to find out, when you reach here, what is the help point that you have. There will be some requirements, let's say, but this is the damage that I'm talking about. This is D for damage, okay? And this is the requirements. There will be some requirements, and now I'll have to add this. If I started from here, I'll have something different health point here. If I start here from here, I'll have different health point. If I করে দিয়েছি ওটা করছি, হ্যাঁ পেন্ডিং আছে, ওটা এখনই একটু আগে করলাম। হ্যাঁ একটু আগে আসছিল। So now what can we do? Well, I need to know, I already know the sum in order of 1, but it's not what I need. I need how many times will this sum be able to fulfill this particular requirement? That's what I need to find out in order of 1. Correct? That's what I really need to find out in order of 1. And how can I do that is the important question. All right, this is a hard question. Basically what I need to find out is how many times I'll be able to fulfill the requirement if I started from here. Okay, so it is just equal to, so okay, if I started from here, here or here, how many times will I be able to fulfill this thing? Okay, and what is the minimum health point, or maybe what are the health points that I get, and in that health point I'll be like, okay, only try to, when you are here I'll be like, okay, now subtract 10 from those health points. Now how much are you left with? That works. I can really use a segment tree, to be honest. I'm thinking maybe I can use a segment tree. Maybe. Or maybe I can use sets. Or multisets. Sets or multisets. Yeah, sets or multisets works. So my thinking is try to add the damage, and now when you are here, when you come here you will be like, okay, when you started from here, when you started from here, when you started from here, you were, in the end you will have how many of the health points are there. So it will be like all of them, there will be in sorted order, and I need to find out by binary search. Yeah, maybe I think I can do binary search. Yeah, binary search. Yeah, binary search works. Binary search using and multi-sets. Yeah, that's good. Yeah, the only thing that I need to do is implement that binary search algorithm. Actually, I don't need to apply binary search algorithm, to be honest. I just add health points. I'll have some health points, correct? Lot going on here, and then I'll be like, okay, how much health point will I add here? Some different health point, to be honest. Okay, this is getting harder. This is actually hard. And multi-set, even if I remove them, it's again the same thing. In the multi-set, for each of them I'm still doing the same thing. Okay, I'm unable to think right now. Let me eat some Oreos. Maybe my brain will so what I need to do, if I try to be brute force C from here, okay, all right. If I start from here, right, and HP is going to be in a decreased fashion because D is going to be in an increased fashion. And there are also going to be requirements, right? And I'll be like, okay, HP minus this, HP minus that. How many times this requirement satisfied? Okay, I can maybe do something like but that would be n log n. Okay. So if I'm at a particular index I, let's say, right, and how many times will I be able to complete the requirement? Well, so it's asking basically how many times, starting from that index itself, how many times the health point is just greater than that particular requirement. How many times will that happen? And how can I find it out? When it is here, I can calculate the damage. So so it's basically HP minus D of, let's say, I, correct, plus D of some J minus 1. So from I to J it will give me the health point, and if this is greater than requirement, I'll add it to the answer. But this is the thing, for a given I, these two things are constant. This is what variable is. I need to find for all the J's. When I'm here, when I'm at that particular index only, when J is I minus 1, J is I minus 2, and so on. How many times will that be greater than requirement, or requirement of I? Or in other words, I can also say how many times this will be minus plus dp of I, d of I minus hp. How many times is this going to be greater than, so this is going to be something I don't know, and I just need to find the number of times in it's going to be, and how can I find this faster? Right? How can I find this faster? So there are this many damages. J can be I and 1 and anything. How many times? And up to 1 only. It cannot be less than 1 to I. 1 to I. This can be. And how many times will it be greater than this particular thing? And I'll be like, just find the answer in order of log n. How? I think I got it. No, I didn't. I don't think I got it. I want to find it in log n. If this is true, then I'll return 1. If this is false, then I'll return 0. Correct? And I don't know if this is going to be in log n, or I have no idea. Correct? I can only try. This is not log n actually, if you think about it. Looks like log n, but it's log n log n. It's worse. You divide, and in each of them you try to process n plus log n. I think this will be, right? It's worse. Log n, find out this one, and then it also finds out this one. This is not log n, right? I need to apply segment trees or something like that. It will find it in, it is going to find the answer in just a matter of time. It's not actually going to find it. I just need a data structure that can find what I'm doing here fast. And this is not really log n, it's n log n. I think so. Or n plus log n, whatever it is. How many times? It's just greater than or equal to this thing. That's it. That's what I need to find out. That's it. Well, one other thing. Oh yeah. One thing to notice is that this is always increasing. This thing is always increasing. So I just need to find the index, right? I just need to find the index, and I can find the index by binary search. Correct? And because this is always increasing, that's for sure. Or maybe I can just use 2 pointers, man. I can use 2 pointers. Yeah. Oh my god. So bad at doing. Okay. So let's do this. D, which will be n plus 1. And yeah. For anti I equals to 1 less than n, I less than equals to n, I plus plus, and n I have not written here, so n is just damage dot size. And now d of I is equals to damage of I minus 1. Correct? Alright. Okay, now I'll have a pointer I, or maybe I'll be j pointer, and I'll have a I pointer. J pointer is going to be at 1 and I is going to be at 0. Correct? And I'm going to be like, okay, for int I equals to 0, I is less than n I plus plus. Do this thing for me. Okay, and I am also going to have a long answer. Okay, now this is a 2-pointer question that I didn't really understood. Okay, so now yeah, so requirement of I. So while d of j minus 1, and this is actually is going to be I plus 1, correct? If you think about it, you are not at ith index. If you are at ith index, it will be I plus 1, correct? And this will be, this is all right. So while dj is less than requirement of I plus d of I plus 1 minus hp, I will like do j plus plus, and when so answer plus equals to, it will be I plus 1 minus, I'm at that particular j, so I plus 1 is that particular I where I am currently at, and that particular j in which, so I plus 1 minus j plus 1, right? I plus 1 minus j plus 1. So yeah, so I plus 1 will be where am I at, and j is 1 initially, obviously. Maybe I can just start this with I, so I'll have to do this instead, and this will be hp, correct? And I'll be like, okay, do j plus 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 plus, and one more thing, and j should be less than, because j should be less than or equal to I, correct? If you are greater than I, then I'll be like, okay, I minus j plus 1. Correct. So this is going to be, I is lesser, j is more, 1 more than I, then answer will have just a 0. Okay, you are now you will be like, okay, even though that's greater, this is not linearly increasing, right? Even if this is linearly increasing, this is not really increasing. I'll have to do binary search. There is no other option, to be honest, correct? I have no idea. So maybe I'll have to find this is a particular x that I need to find, and I need to find dj minus 1, which is just lesser than this x. So let me copy paste this. Yeah, okay, so yeah, now I'll do a binary search on this. Now how can I do a binary search? Well, I'll just be like, okay, and p equals to 1, q equals to I, and some r is there. I'll like, okay, p is less than equals to q, and r is equals to p plus q by 2, and now I'll be like, okay, do the binary search already. Why are you not doing it? Yeah, I'll do it. So you are at I. So if d of r minus 1 is greater than x, then I'll be like, okay, r equals to q minus 1, correct? Else if it is lesser than r equals to p plus 1. If it's lesser than x, I want it to be greater than x, right? If it's lesser than x but I want it to be greater than x, so I will do this. And now what the answer is going to be? Answer is going to be this thing, right? P plus 1 or whatever r will be. Okay, I think I did mistake. P is equal P is equals to r minus 1 and P. Sorry. If it's still greater than, I'll be like, okay, Q is equals to r minus 1, and here I'll be like P equals to r plus 1, correct? This is the thing that I'll most probably do, and I'm like, okay, yeah. So and if it's not even there, the P is just going to be outside of it, so this is fine, I think. So P is the thing, because if it's greater than, I'll be like, okay, move on to the shortest distance. So this is going to be thing, and I'll just going to return the answer. I think this should work. Okay, typo here. Okay, it didn't work. What happened here? Is it wrong? Whatever I did, is it wrong, guys? Is this thing that I did, is it wrong? Shouldn't I find the smallest distance where? Okay. I think I did not do this. Yeah. I minus 1 plus. Yeah. Achha. No, come on. No, come on. Yeah, let me submit this now. I did got accepted. So yeah, it was a binary search question and didn't really realize. I wasn't really realizing for a long time. Yeah, even though I have did a lot of binary search questions, still. You are given an undirected tree. Yeah, tree. I like trees, although I cannot solve the problems, but I still like trees. Who doesn't like trees? It gives you oxygen. And you are given an undirected tree with n nodes number from 0 to n minus 1. It is represented by a 2D integer array, edges of length n minus 1. Okay. Yeah, got it. And you are also going to where edges I indicate that there is an edge between nodes AI and BI. Right. Represented by 2D integer array. Okay, where edges indicate. Maybe this is a binary lifting question, and who knows? I'm just guessing. This is a tree, and then the first thing that comes to your mind is binary lifting. Although I don't know how to implement that properly, but yeah, I still have time. Actually, I don't have time, but yeah, I'll just try to be as fast as possible. And yeah, this indicates that there is an edge between nodes, and in the tree you are also given an integer array good, where good I is 1 if ith node is good, and okay, right. Define the score of a subgraph as the number of good nodes minus the number of bad nodes in the. Okay, so what the heck is this? Like, I just need to, for a particular subarray, I just need to know the total number of good arrays and the total number of the size of the subarray. That's what I need to know. These two things are enough. Number of good and the number of the number of total size, basically. If I know these two things, I will be able to calculate it for all of the things. But how do I do that is the main question. Yeah, for the subgraph this 0. Yeah, at first I'll need to make the undirected graph for this. And yeah, in tree there is no way you are going to end up, there is no cycle basically, right? This is a really good thing, that there will be no cycles. It's from 0 to n minus 1 is, so I am doing this. Yeah, so for vector int p in edges, I'll be like, okay, int u equals to, or maybe just, yeah, int u equals to p of 0 and v equals to p of 1 and g of u dot emplace back v, and yeah, I don't really want to traverse back, correct. Okay, so if that there is a edge between nodes ai to bi, yeah. All right, so I'm just going to be leave it at this thing. This way I'll know what. So for this whole thing can be a subarray. So I don't want that. I just want to be precise that this is the subarray that I need to work on. And yes, there should also be a value for the node, but I don't think so, because if you are at a particular node u, you can just find out if it is good or not by this thing. Okay, so I need two things. I need the size and I need the total number of good for each of the particular array, right? So the first thing that I also want is to find the parent. What is the parent of this node? Like, what is the parent? Is there no parent? As you can see, there is a node. Okay, there is just an edge. What is the parent? I'm unable to think about that. How do I find it then? Like, how do I find that if this is a subgraph, then the subgraph of 2, and if this is the parent, then this is going to have a subgraph of 1, this is also going to have this will be also a subgraph of size 1, and this is going to be a graph or subgraph of size 3. But if this was the parent, then this will have a subgraph of 3, this will have a 2, and this will have 1. So I need to know which one is the parent, and I am not seeing The parent really. The edges A to I just indicates that there is an edge. It does not indicate if it's really What are all of the subgraphs? What do I need to return? Every pair of vertices is reachable from a connected subgraph is a subgraph in which every pair of vertices is reachable from one another using only its edges. What? These vertices and edges are subsets of original graph. Alright. A connected subgraph is a subgraph. It is a subgraph in which every pair of vertices is reachable from one another using only its edges. What does that mean? Subgraph is a subgraph in which every pair of vertices is reachable from one another using only its edges. Okay. Connected subgraph in which every pair of vertices is reachable from one another using only its edges. Okay. Find the maximum possible scores among all the connected subgraphs. Okay, so this is every pair of vertices using only its edges. This is a subgraph. This is a connected graph. I don't understand. What does that mean? Well, is this a subgraph? Yeah, it's a subgraph, but because it's a tree and as well as a thing. But is it a connected subgraph? How do I know that? Every pair of vertices such that this can only be of its vertices is reachable from one another using only its edges. Yeah, so I can if I talk about this vertices, I can only its edges I can reach any of them. So what's the big deal? Is this a connected subgraph? This is a subgraph first of all. Subsets. Oh, it just has to be subsets. Graph. Okay, right. So what do I need to find out? Right. For each node I, find the maximum possible score among all connected subgraphs that connect. Alright, yeah, I got it. I think I got it, guys. Yeah, I have to do this. Okay, now what do I need to do is what do I need to do? That's the important question. What am I doing with my life? Why am I here solving leetcode problems? Why am I giving this contest? knowing that why am I even solving this problem, knowing that I will not be able to solve this? Still, I'm trying my best. It's because I want to be a good man. But what does? Oh, fuck me. Okay. So, yeah. So I'll try to. Yeah, I think I need to use dynamic programming in this one. Not even dynamic programming can save me, I think. I need to find. Yeah, I think I can do it. So maybe I'll have a DP for all the node, which will give me the best possible scores. Okay, and I don't want it here. I'll try to do it vector int dp, and I'll be like, okay, dp dot assign -1 maybe initially. Okay, and now I'll be like, okay, let me try to score, right, int u. I'll also have a vector of vector in G, vector which, do I need to care about visited arrays or something like that, or no? Do I need to have a topological order in this? Fuck. I don't think DP will work, and I don't really think it will work. Okay, so what is the constraint here? Okay, so the n is just 10 to the power 5, right? And there will also be some edges as well, and I'll be like, okay, for each one I'll have new visited, which is, yeah, I'll get a TLE in the way I'm thinking of solving this problem. Alright guys, I think that's it. I think I will not be able to solve this problem. I think that will be it. What can I really do? Using DP, will it help me? It will not help me. It's just not going to help me. Crazy. This is an interesting problem. I think I'll give it a try. Okay, so that's it guys. I think I won't be able to solve this. I'll just check my rank quickly in this virtual contest. It's still bad as ever, but no worries. I have worse ranks. See this, man. This is also worse. I mean, they're all worse. This is at least good. Okay, thank you guys for watching.